Hello and welcome to this webinar hosted by Threepwood Consulting, which deals with the evolution of networks. First and foremost, I'd like to thank you all for joining this webinar, where our panel of experts will pass on our knowledge and experience of subject matter so that the electrical engineering community you represent are better informed when making important engineering decisions. This presentation will be driven remotely, so please bear with me when I say next slide. My colleagues do. It's just the way it's actually being set up. Ian, could you? Yep, that's it. Okay, so my name's Chris Parkinson. I'm an electrical engineer and I work for Threepwood Consulting as a principal consultant. As you can tell by my accent, I'm from the northeast of England, Newcastle upon Tyne, and I'm currently sitting here delivering this presentation. And I'm joined by my esteemed colleagues, Mr. Ian Ross and Mr. Gary Eastwood, who are getting ready backstage and will introduce themselves shortly. For anyone who hasn't really heard of Threepwood, we're an independent electrical power consultancy who are based in the north of England, and that's Manchester, but we do have satellite offices at various locales throughout the UK. And many of the consultants within our organisation have worked for UK electricity companies. We are heavily involved in the development of operational health and safety management systems and documentation, including standards, specifications, codes of practice, electrical safety procedures, etc. And coupled with that, we also deliver network studies, and we also provide external safety audits and carry out QMS and OHS operational health and safety audits to both 9001 and 45001 respectively. A little bit of background on myself. I've spent 30 years plus in the electrical industry with experience at all voltage levels associated with generation, transmission and distribution systems. I was with the UK, what is now called a distribution network operator, but it was a REC when I was a boy. I was there for 18 years. Gradual progression through the industry from the tools, I was electrical fitter to a second engineer, basically. I also spent a number of years in contracting, looking after independent networks, managing those networks, and also asset services. I have been a consultant now for approximately 15 years and consulted globally. Actually spent a year in Abu Dhabi working for their version of Ofgem. So I was assisting the DNOs across there as well with their health and safety matters. I suppose my specialised subject area is electrical safety rules and operational procedures, and that's something I have a passion for. So that's enough on me. And I'll get my colleagues to introduce themselves, please. Gary, could you introduce yourself? Come online.
Yeah. Thank you, Chris. Good morning, everybody. I'm Gary Eastwood, Managing Director and Principal Consultant at Threepwood Consulting. Like Chris, I started in a REC, not as a REC, hopefully. And I'm in my 30th year now in the industry. I started out as an operational engineer with one of the DNOs, Midlands Electricity Board, which is now Western Power Distribution. And I was senior authorised there for all voltages and systems. And for the last 15 years, I've been working as a consultant, and my specialist areas and interests are electricity network safety and operations, and also the auditing aspects, which we'll talk about later. My passion for this subject comes out of personal experience of, in particular, a high voltage accident that happened at Midlands when I was a young engineer. So I have a passion, and no doubt a lot of you on the call will do, about this subject. Outside of work, my main interest is learning Italian. I've been doing that for 3 years. I'm plugging away, and I like to visit Italy when I can with my wife. Thanks, Chris.
Thanks for that, Gary. Ian, would you like to join us, please?
Yes, morning everybody. I'm Ian Ross. I'm a principal consultant as well for Threepwood, specialising in health and safety and asset management, and I'm also from the glorious northeast of England. As of September this year, I've had 28 years working in the power industry, which was a bit of a surprise to me. So I started as a 9-year-old apprentice electrical fitter for what was then Northern Electric, I worked in numerous operation roles up to 132 kV with many years as an SAP on transmission, distribution and private networks. And I had several years working overseas, looking after transmission, distribution as well as generation assets. And for the past 7 years, I've been working as a consultant for Threepwood, working across a wide range of DNOs, IDNOs and private network operators, both in the UK and overseas.
Next slide, please. Thanks for that, Ian. Okay, a little bit of background and a little bit of housekeeping this morning. The running order for the webinar, we will basically, it'll be put into 3 sessions, possibly 4 with the Q&A. Session 1, Mr. Ross will discuss the evolution of networks and technologies. Session 2 will be technical and human challenges delivered by our Gary Eastwood. And then I'll basically summarise with some conclusions and some reflections. And we will have a Q&A session at the end. Next slide, please. As you've no doubt seen already, the webinar is a listen-only event, and we welcome your questions via the meeting chat function. If you find this out, it's on Teams. Click on the 3 dots and you'll see the chat. So please post your questions there for review by the webinar moderator, and hopefully those questions will be answered at the end of the presentation. Again, if you experience any technical difficulties, it says please issue or submit via the chat function. All I would suggest is the webinar itself is actually being recorded. So if there are any technical difficulties, we will be sending a link out at the end of this presentation, and you can obviously view and download in due course. And also on completion, we will be issuing a feedback survey, and we would welcome that you complete those surveys, because at the end of the day, we're here to live and learn, and feedback is very important in that cycle. Next slide, please. Okay, so with further review, I'll hand over to Ian Ross, who will be delivering the next part of the presentation or webinar on the evolution of networks. Over to you, Ian.
Thank you very much, Chris. Right, so that's enough about us, so let's get into what we're all here for. So morning, everybody. As we're probably aware, electricity networks always evolve. However, over the last 10 years, the evolution has really gathered pace somewhat. Once upon a time, the flow of power was a simple progression from the power station to the consumer in a very linear fashion. It started generated to transmission, then transmission to distribution, then distribution to consumer. Nice and simple. However, now that picture is a lot more complicated, with distribution generation, energy storage systems being commonplace on all parts of the system. The nature of the works also evolved over the years. Once there was a very local workforce with specific knowledge in their area of expertise. There was less commercial pressures, meaning the training could be longer, more in depth. And the modern workforce seems a lot more transient, frequently moving between different types of network, different companies, and in some cases different countries. There's also been large swathes of experienced people that have retired, and often the recruitment of new people didn't quite seem to keep pace with that. Some people might remember having a cable specialist or someone like that. They were frequently seen as an expensive overhead by the management, and if they were replaced, it was usually with a more generalist engineer. But throughout all of these changes, the nature of the network and the methods of working, the dangers inherent when working on electrical networks have always been constant. They're always there. And arguably, due to the factors we've just mentioned, the actual risk has probably increased.
Excellent. Ian, just a point on that, I suppose, with regards to evolution, do you think people are busier now or have more responsibility?
I think they're certainly a lot more fragmented. People probably are busier. There's the workforce is generally smaller than it was. And yes, I think people are, and because of the added pressures of the network changing, they do have more responsibilities these days than they used to.
Thank you.
So how do we go about thinking about risk? Well, the management of health and safety work regulations, more often than not known as the management regs, specify something called the principles of prevention. And from these principles of prevention, we can derive a hierarchy of controls, which are very effective guidelines for reducing risk. So unfortunately, the most effective methods, which are elimination and substitution, aren't really that practical to us. If we don't have any electricity networks, there's nothing to worry about. We could completely remove any risk. probably none of you would have registered for this webinar though. Substitution can sometimes be used primarily through remote operation of plant with SCADA systems, lanyards occasionally. However, that's not always a viable option. If we then go down to the bottom of the triangle, we've got PPE, which is pretty much well understood, well utilised within the industry, I think. But it's technically the least effective method of reducing risk. It's very much the last line of defence, provided you're actually wearing it, obviously, as well. So these days, a lot of companies put a lot of time and effort and money into carrying out arc flash studies. However, the results invariably lead to the need for further PPE purchases, increasing the FR rate in line with the findings of the study. Although arc flash studies do have their uses, it's generally more effective and cost efficient to concentrate your efforts on the engineering and administrative controls to create safe systems of work so that you can effectively reduce risk, isolating people from the hazard and changing the way people work.
Ian, just one point there. You went through the hierarchy and you've described the various elements eloquently there. You missed out the engineering controls and the administrative controls. Could you just...
Yeah, we'll talk about them a bit more as we'll go on, but the engineering and administrative controls, you can have interlocks are a good example. You can design interlocks into a system to sort of they're more of an engineering control, and also the way we carry out operations on the network, the way we switch, the way we isolate, the way we earth, the way we issue safety documents, they all fall into that sort of group of keeping people away from hazards or changing the way that people work. So how can we help people reduce the risk? The best way really is through safe systems of work. There's two main methods of implementing safe systems of work. You've got training and you've got policies, procedures, codes of practice, which we'll go into a little bit more detail on those later. Both methods individually and in isolation can be effective. An example of a highly trained workforce, fire service. They spend a huge amount of time trained for every conceivable situation. Obviously when they're not putting out fires or rescuing cats from trees. A good example of detailed procedures is IKEA. Personally, I've had no formal training as a cabinet maker, but I can knock up an IKEA wardrobe fairly easily by following their instructions, provided the pieces are there. But in reality, most companies sit somewhere between the two, a balance of both. There's no right place to be, but what's fundamentally important is the quality and accessibility of each, and they both complement each other. And this is where your context becomes important. You may consider your risks to be low. For example, a repetitive task carried out over a long period of time can lead to competence without much training. If a site, for example, has one high voltage circuit breaker that's manually operated twice a day to turn a large pump on or off, the training would be minimal and there's probably a very brief procedure tucked away in the back of a drawer somewhere. The flip side of that is an example of airline pilots. They're highly trained, but they always carry out the same documented checklist before takeoff due to the critical nature of what they're doing, which I'm sure we're all happy about. So as we mentioned before, because the nature of the network and the work has changed, there isn't always the specialist knowledge that there was before. This is where documenting procedures can bring huge gains to an organisation.
So just to clarify, Ian, companies can either put in place detailed instructions for managing risk, or they can rely on personnel and their knowledge and skill sets. Is that correct?
Yeah, because they can do both. It's best to have a blended approach, really, where you have your procedures and your procedures can guide your training, then you're trained in it, then you've got your procedures to fall back on, and it gives it a very circular feel.
That's understood. Thank you.
So the best way to illustrate safe systems of work and how they look is to use the Swiss cheese model, which people maybe have seen with the recent COVID methods of dealing with. So if we consider the relatively simple action here of operating a high voltage switch, there's numerous barriers in place to create a safe system of work and reduce the risks of the operator from the hazard to an acceptable level. So if we look at all of these different bits in isolation, all these barriers, you've got design. So in the design function, before there's any switchgear there, there's procedures should be in place to design risk out of the system wherever possible. That really is quite key, that you should be designing risk out. The designers will be following technical specifications, they'll be specifying interlocking functions, and they'll be doing calculations to ensure fault levels are within capabilities of the plant. Then we'll move on to the procurement people, who sometimes can be a little bit of a pain, but they do serve a function, which is to correctly specify plant and they'll ensure that the relevant standards are adhered to by the use of factory acceptance testing and things like that. So once we've bought it, we'll get on to putting it in. So the installation side. So generally you have to install things according to the manufacturer's instructions, but then there's other considerations such as the foundations, the building, the roof, the doors, ventilation, trenches, trench covers. All of these things need to be to a suitable standard. So once it's been built, you then need to commission it. Very important part of it. So the commissioning ensures the final checks, make sure everything's correct. You'll test it to prove the functionality of many of the components. And an added benefit of commissioning is that it gives you a baseline that you can assess its condition in the future to. So once it's been commissioned and it's in service, you'd like to think it's being maintained. So for it to be maintained, you would expect to have a maintenance policy which defines the expected conditions that that plant should be in. And underneath the maintenance policy, you'd expect to have some procedures, work instructions, detailing methods as to how to maintain that piece of plant in its expected condition. So then we get into the operations, which is what we're actually doing here. You'd expect to have some electrical safety rules outlining what you can and, more importantly, what you can't do. And underneath the electrical safety rules, you really need to have a solid suite of approved procedures and really showing you how to achieve those safety rules with some control procedures as well. To the side of that, you need to consider some corrective actions. You need to have some procedures in place for that, particularly defect elimination. You want to know things have been fixed on it. You'd like to have a method of identifying and completing manufacturer modifications. And there's also something called the NEDA scheme, which is run by ENA, which identifies failures of plant and gives some guidance along those lines. And then we'll get on to the person that's actually doing the operation. You'd like to think they've been trained in the procedures, and also for some of the previous things we've mentioned, training to ensure competency. And hand in hand with training is assessment. As part of the assessment should be that people are competent and they know what they're doing, and there might be an authorization structure as well, which authorizes people to do certain types of work. And then last but not least, we'll have the auditing. The auditing gives you assurance that all of the aspects that we've just talked about have been carried out correctly. And as you'll see there, there's a lot of barriers to prevent any harm coming to the operator, but every barrier that isn't in place increases the risk of an accident occurring.
There's many factors there in which we have to consider, and I think generally we do that as a matter of course from our experience in the industry. But from your experience, when you've done audits, etc., are there any areas which organisations commonly fail?
Yes, there's very few that do everything 100% perfectly. What I have found is that in the renewables sector, wind farms, solar, the design, procurement and installation, and sometimes the commissioning seems to be a bit of an area of weakness. And some of the more larger network operators, the maintenance can sometimes not be great. Corrective actions isn't always great. So it really varies between parts of the industry, but as I would say, I don't think anybody's excellent at all of it.
Thank you.
So if we're going to safe system of work documentations, there's lots of different types of document in the safe system of work, all with very different intents. So the triangle on the left indicates the number of documents of each type you would generally expect to have, as in not that many policies, but quite a lot of procedures. And each document has an intended audience. So policies are good for senior management, as they can state the direction, the intent the company wants to take. Standards and specifications are generally the realm of designers, planners, showing them what they need to achieve. And codes of practice and procedures are good for people carrying out the work, so it shows them what they need to do to adhere to the policies and the standards that I've previously talked about. You might not need to have so many different types if you're in a smaller organisation. The purposes can sometimes be combined if necessary, but the most important thing when writing these documents is to always keep in mind who will be using them and what they'll be using them for. Accessibility is really the key, otherwise they likely won't be used. And the other thing about documents is they need to be living, they need to be reviewed, they need to be relevant, they need to be up to date. And they don't just have to be text either, videos, pictures. They can be extremely effective at getting relevant information across, particularly videos now with the younger generation, as I like to call them. And I think fundamentally with a good, well-organised suite of documents, any new technologies you encounter, any new work methods can be easily integrated into a business as usual approach.
I'm sure you'll all agree that something that's key here when you do develop these policies, standards, codes of practice, or whatever, it's the line of sight, and you need input from top to bottom and bottom to top. I'm sure you'll agree with that, Ian.
Absolutely, Chris. People need to know why they're doing something, because if they just blindly follow something without understanding the reasons for doing it, you don't get the buy-in that you need to be successful. So at Threepwood, we've had a lot of experience in creating and assessing safe systems of work across the industry. So consequently, we can identify areas that most companies should focus their effort. So we'll go through a few here. As I mentioned earlier, the content and purpose of documents can vary. We do find a lot of the time that documents tend to include elements of policy as well as more detailed instructions, which invariably leads to a one-size-fits-none solution. These type of documents they're not very accessible, and often the relevant information that somebody wants can be difficult to find, and they just lose faith in the documents. Training courses as well, they can sometimes be a little bit on the stale side, and the same content materials used over and over again. And this is particularly relevant if you're dealing with refresher courses, because courses should really reflect the requirements of the business. They should be trying to raise the overall standards by drawing from the findings of audits and investigations and really pushing forward. Asset management wise, maintenance intervals can vary greatly between companies. They're normally based upon risk profile, asset knowledge. As found data is tremendously useful to establish a general condition of your plant on your network, but it's frequently overlooked. Trip testing circuit breakers, that's an excellent idea to ensure they work when they're called upon. Program a periodic time in the initial test of each circuit breaker is probably one of the most effective maintenance strategies to implement, because it gives you confidence in the safe operation of your plant. Solid set of safety rules as well. They should be the bedrock really for any operations on the system. They reduce the risk to someone out switching on your network by clearly identifying what you can and what you can't do. But underneath those, there should always be a suite of approved procedures, identifying amongst other things, safety document requirements, switching procedures, testing procedures, cable identification procedures, PPE, working at height, working in compounds. I could probably spend the next 10 minutes going through them, but I won't. Authorizations as well, they should really correctly limit the actions a person can carry out based on the general risk of actions and the person's training, person's assessment. And last but not least, again, is audit, and it's the final piece of the plan, do, check, act circle. And if you've got a robust audit regime, it will identify areas of weakness in all of your safe systems of work, and it'll enable you to refine and improve them to further reduce your exposure to the risk. And that's all I've got.
Thank you very much for that, Ian. Very eloquent and very well put across. Been a very informative presentation indeed, and I think there's many learning points that we can all take away. I mean, from my own point of view, in particular, there's this need that you do have to have a robust system in place, and that it's not just off the shelf, but it's fit for purpose, i.e. it's bespoke to your organisation, so that when it's implemented, it will enable your organisation to achieve its intended outcomes.
Absolutely, absolutely.
Okay, so thanks again, Ian, for that. Moving on, I'd like to introduce Gary, who will be doing his element of the webinar with regards to the challenges we see with evolving networks. Over to you, Gary.
Yeah, thanks very much, Chris. And Ian, thanks for setting the context of how HV safe systems of work have evolved. I think that's very interesting. Well, in the next 15 minutes, I'd like to talk about some of the challenges that we see in our electrical safety and auditing work. I'm going to discuss a selection of current topics from our work with DNOs, renewable generators and private network operators. So as Richard's put in the chat, please feel free to ask questions as we go along, put them in the chat function, and as we get to the Q&A session, I'll be happy to address these at the end. Just next slide, please. Just to kind of set the context here, we're going to be talking about human and organizational factors, technology, and processes and procedures. If I just kind of focus first of all on the human and organizational factors, the recent research that was carried out by the Energy Networks Association, the ENA, on behalf of its electricity network members, has identified a number of human factors and organizational factors that impact on the safety of HV operational staff. Now, this evidence was gathered through many consultations with hundreds of SAPs, authorised persons and competent persons across those network operators. And a number of positive factors and challenges were identified. Common positive factors that were cited were, the evolution of strong safety cultures in the organisations. I remember joining the industry when, it was difficult to get a guy to wear a hard hat, and now we have come a long way and people are genuinely committed to safety. And also the culture that promotes operational people to challenge each other, the competent person challenging the SAP and vice versa. The positive impact of good relationships between SAPs and competent persons can have a big positive impact on safety outcomes. And this was recognised together with the importance of having mutual understanding and good communication between the role holders in these safe systems of work. However, a number of key challenges remain. I'm sure most of us will have experienced a challenge from lack of skilled resources, in particular senior authorised persons. And as Ian said, the impact that this has then on individual workloads we've seen, and this often materialises in long working hours and fatigue across staff, which is a factor in accidents that we see. There's also, for many network staff and private network operators, perceived pressures from management to keep the lights on and to meet restoration targets. And for those staff, these pressures are real and pose a dilemma for the people in terms of getting the job done quickly versus getting the job done safely. When you factor in lone working, when you're under pressure, this can affect decision making and the propensity to take risks. I think as well, the provision of adequate support and supervision has a fundamental role to play in an effective safe system of work. This is in terms of ensuring the work's adequately planned, there's adequate and competent resources assigned, and it's been adequately risk assessed. And as we know, every site and substation installation can differ from another. As well, we have a need for regular monitoring of compliance and supporting operational staff. And there's a need for supervisors through additional training to better understand the psychology of people. How do they tick? How do they behave under pressure? And how does this impact positive safety outcomes? A common output from our audit work is many companies don't have adequate operational monitoring or audit regimes in place. And if we think about the first slide, Plan, Do, Check, Act, this check element can be really helpful in identifying lack of compliance with good operational standards and poor practices. In our work, we see the positive impact that regular sampling and checking of completed safety documents has, such as permits for work. It can identify pretty quickly poor practices, and it can identify those high-risk individuals where interventions such as retraining are required to maintain good operational standards. Those of us in management positions, I think, have a really important role to play in addressing human factors by actively managing workloads, encouraging staff to flag up, engage, and positively act on signs of pressure and tiredness, and ensuring that we put adequate support and supervision and monitoring in place for operational staff that will reinforce positive behaviours and reduce risk taking.
Carry on, Gary.
Yeah, just going on, so on to shared learnings. So Another challenge is the limited way in which learning from operational incidents and accidents across the industry is shared and communicated, and that includes getting it right down to SAPs and CPs. Often detailed learnings and recommendations are held back within individual companies until inquests and court cases are completed, and this can take years. Every opportunity should be taken to seek out, to record and communicate learnings from near misses and operational incidents to HV staff, and as important, contractors these days, who are an important part of our workforce. And again, we all remember a good story, don't we? When we communicate in bulletins, we generally tend to remember why there is a requirement if we remember the accident or incident behind it. However, we do find a number of companies don't take this opportunity to do this through regular operational bulletins or as part of refresher training. Such bulletins and briefings can help reinforce procedures. And another added benefit is it can help to act as the corporate memory about high voltage incidents and the lessons learned. Oh, Chris, I think you're muted, sorry.
Sorry. Thanks, Gary. Listen to that intensity there. I'm just wondering, is there any good reference material out there for sharing learnings? Is there anything we could, refer to that would give us structure on how to do this?
I mean, one thing we look at with auditing is we look at the ISO standards. So if you look at ISO 45001, which is safety management systems, again, that recognises the important part of consultation with workers, engaging with the workforce and communicating near misses, hazards backwards and forwards. And also 45003 is a useful reference which talks about the human factors and psychological aspects of safe systems of work. Just building really upon this, I'm going to speak particularly for the renewables industry here, because we have found often questions we get asked are around EN 50110. There's a desire by some companies that operate across Europe particularly to harmonise their safe systems of work. And this is particularly the case where their safety functions are centralised rather than localised. And again, their workforce works across different geographic territories. So yeah, we recognise the benefits that operational persons working to a common set of safety rules and procedures can have, as well as common authorisation levels. However, we see significant challenges to overcoming this when we consider an approach, in particular considering the adoption of EN 50110 as an set of electrical safety rules. Whilst this standard presents common principles and a common framework for the operation of those electrical installations, I think we should recognise that, as the standard does itself, that it's only a step in the gradual alignment in European safety requirements for work and operations on electrical installations. Whilst the requirements in the EN 50110 do form a real good basis for developing a set of safety rules, the standard does not, in our opinion, provide sufficient detail to be implemented as a set of electrical safety rules in its own right. Indeed, we see real problems when considering this approach, not least because the requirements in EN 50110 are minimum requirements and somewhat generic. They need to be, given they're applying to more than 30 countries across Europe. We see a risk with this approach in deviating from tried and tested UK-style safety rules, and often derivatives of the ENA's model distribution safety rules, and for those some operators, the national grid safety rules, which have evolved over many years and not least have addressed many learnings from previous incidents. And one such example is, the hierarchy of local and remote control of switchgear that, we've evolved over years now to keep people away from equipment, which isn't addressed in 50110. I think as well, the different legal context and safety legislation in the UK such as the Electricity at Work regulations, which is specifically and should be specifically addressed in electrical safety rules and accompanying procedures, is not catered for in 50110. Part 2 is just simply a list of legislative references. It doesn't specify how to comply with that legislation and code of practice. So I think in summary, our experience shows that HV safe systems of work need to be based on the development and implementation of clear, consistent and comprehensive set of electrical safety rules that suit the organisation and which are supported by more detailed and prescriptive procedures and guidance to support field operatives. Excuse me.
I think, Gary, you touched on that there, that 50110 does come in two parts. The first one, yes, it shouldn't be adopted as safety rules per se. You should use the guidance within this to develop your own. And let's not forget, you know, safety rules should be developed in the context of the organisation that uses them, you know, and their networks, etc. So they have to be bespoke for that organisation. But part 2, as you rightly said, that does offer some good directory material. Well, it redirects the reader to legislation and guidance within the UK and indeed in European environments as well.
Yeah, I think the model distribution safety rules, the old the National Grid rules and 50110, you know, again, we've done a lot of comparison and gap analysis. But you're right, Chris, it does come down to your organisation, your context, and taking those good principles and putting them into something that works for you. If I just move on now to competency and authorisation, we do see issues with assessing the competency and authorisation for persons, in particular the staff working for contract organisations and independent connection providers, the ICPs that work on different high voltage systems and under different electrical safety rules. The HSE themselves has concluded that between 2002 and 2017, some 13 fatal incidents involving SAPs and or authorised persons that had occurred on electricity networks involved authorisation and setting to work issues, and sadly 9 of those were electrocutions. So this area of getting the right competency and the right authorisation is so important. You know, for simple HV installations with single sources of supply, the issue of authorisations with contractors can be overcome by the network owner transferring control of the HV system, all of it or part of it, to suitably authorised persons, for example, contractors. And this allows the contractor to apply their own electrical safety rules and safe systems of work to that part of the customer's HV system they have control of. And this is a common and established arrangement, such as a control operation and maintenance agreement, or COMA. However, we see issues and where the client network owner wants to apply their own HV electrical safety rules when it comes to contractors, and to decide whether they should be specifically appointing and authorising these people under their own rules. In our experience, there is scope to recognise competency and authorisations made under other safety rules where such competencies and authorisations are similar. This is providing that the client or owner safety rules allow for this. And again, importantly, there's some form of gap training and assessment in the particular safe systems of work requirements between the client CSR and procedures and those of the competent and authorised person. As a minimum, and the HSE acknowledge this, there is a duty holder requirement here to carry out such checks and assessments and be satisfied that appointed persons understand their roles and responsibilities under the client's electrical safety rules. Indeed, the duty holder should consider the merits of issuing competency and authorisation certificates to contractor staff in these circumstances. We don't believe it's acceptable to expect persons to work under client-specific electrical safety rules and procedures that they're not familiar with. Where there's a practice of issuing high voltage safety documents to persons that have not been trained, assessed, and when necessary authorised under the client safety rules, then this practice should be reviewed. I would say as well, we recognise, and there are practical difficulties of assessing and authorising transient workers, particularly across Europe and elsewhere. But this should not be an excuse to bypass traditional competence and authorisation requirements. We find staff from these manufacturing type organisations, they are competent in their own equipment, installing it and maintaining it, but they're not necessarily competent when that equipment's connected to the system, and they have to work on under these rules. Where they do not have an equivalent competence and authorization, we believe they should be supervised by appropriately competent and authorized persons.
Gary, just for my own peace of mind here, we've touched on contractors, and it could be just personnel per se. If they're authorised on one electricity network, shall we say, and they are requested to go and work on a similar network elsewhere, it's your advice, or it's your take on the situation, that they should not automatically transfer those authorisations across, and they're not competent to work on that other network, shall we say.
Chris, I would say, if you look at the public electricity network operators, they operate a common set of safety rules based on the model distribution safety rules. They have similar networks and equipment. In those circumstances, there's there's arrangements in place for staff to move across networks, particularly in emergency situations, where the requirement to do detailed assessment and training isn't required because those networks are similar and the competencies are similar, but those companies still will issue temporary certificates, and they may have local staff to accompany these staff, so they're aware of local differences. I would say, what's different that we see is, I'd never seen in an industrial network, HV contactors and different equipment on private networks. I think that's a bit we've got to be careful of. Just because somebody holds an authorization for a DNO doesn't necessarily means that's going to be applicable and that they have the knowledge and competence to work on a private industrial HV network.
Thank you.
I just wanted to say a little about electronic permit systems, not much, but this is something we're starting to see it. They're becoming more widespread. And yes, they can make life easier, particularly on complex and integrated systems like petrochem systems, where they have a complex electromechanical type systems. And these systems range from, people with simple electronic forms where they fill them out manually, to automatically generated permit systems, which are fully implemented where the staff don't have any paper copies, they're emailed and digitally signed. I think I would point out and refer you to HSG 250, which is the guidance on permit to work systems, which recognises, as we have, that there are new risks with this approach that need to be addressed. And these can be things like the danger of copying and pasting incorrect safety precautions from other documents and previous jobs, the ability now to be able to readily duplicate documents, which can short circuit suspension and reissue procedures. Measures are needed to prevent electronic permits from being altered after issue without any trace or communication. And also, that one key worry for us is that the practice of issuing permits at the point of work becomes excusable. We always believe that the whole permit system is based on communicating the permit at the point of work. Our experience shows that the decision to introduce electronic permit systems needs to be carefully evaluated and consulted upon, and that is consulted upon with the people that have to work with these systems. There's a need for a detailed procedure around how the electronic permits are to be generated and used, and that needs to be put in place to address the risks that I've just talked about, including what to do if the software or the system fails. And we shouldn't forget that the operational people themselves need to be sufficiently trained and equipped to implement these new systems correctly.
just wondering, Gary, have you actually come across on your travels across these? Because I actually haven't. Well, I tell a lie. I've seen one on a laptop before, an electronic permit. But have you seen them? It's more common now on sort of portable devices, PDAs, etc. Have you actually seen that in use in the field?
Yeah, you're right, Chris. We've seen across even network operators using laptops to electronically fill them out, then print them and issue them, which has its issues because sometimes unique document numbering and carbon copying isn't provided. So we worry about that. But yes, not too much. It's really the process industries we're seeing this. We expect, again, one of the things around the corner for those network operators with SCADA systems and who are upgrading to, more complex control systems do have and will have this facility if they wish to take it up. And that's the bit we haven't seen yet, but the potential is coming. Just moving on now on the technology side, and again, I'm sure we've all seen the globalization of products and services, including electrical equipment, has extended the number of manufacturers and types of high voltage switchgear supplied into the UK. And in recent years, the growth of distributed generation and renewables and independent distribution networks has meant there's been many more network owners and operators. And their ability to assess the suitability and safety of high voltage equipment and the design of high voltage networks varies widely. On the one hand, you've got very informed clients that have well-developed technical specifications and competent resources. And then you get down to developer type organizations that have sparse technical standards, few such resources, and they have to rely on turnkey providers and often overseas type organizations not familiar with our safety standards. And the challenge we have seen, particularly in the renewable sector and early generation sites, has been the supply of high voltage switchgear and fuse gear that hasn't been specified or manufactured to meet UK operational safety standards. And generally, this equipment has been sourced under engineering, procurement and construction or EPC contracts. And early generations of this equipment were built to a budget. And whilst the equipment might meet certain overseas standards, we found issues that impact the safety of operators and those working on the equipment. Safety features that we found can be missing, which we've traditionally been used to, are things like interlocking, both to prevent maloperation and to prevent access to certain live high voltage compartments. Indeed, we found equipment where high voltage terminals can be accessed via the LV compartments. A lack of clear compartmentalization, which has generally been driven by unusual space-saving arrangements, pose dangers to staff. And that goes back to what I said, the HSE's findings that setting people to work, and we all know metal enclosed switchgear, the importance of that. And so this has meant that, people are unfamiliar and can be unfamiliar with these new types of equipment. In some cases, the isolation arrangements don't eliminate all live conductors from the work area. We're aware as well in certain European territories, isolation standards are different to those in the UK. Things like 3-position switches have been supplied where we're now involved with removing points of isolation in order to apply and remove earths, which can lead to unsafe conditions for staff who have to make the test connections or carry out the testing. So establishing safe system of work on such equipment requires operational staff to be familiar with the physical compartmentation of the equipment before they put people to work. In too many cases, staff do not receive adequate information or instructions, whether that be in the form of operational risk assessments, drawings, or switchgear familiarization training. Often such equipment justifies the development of prescriptive operational risk assessments and procedures to ensure isolation, earthing and safe work zones are correctly identified and established. And sadly, we, particularly going back to the pressures of our modern day, sadly, we find this lacking. There tends not to be the time to bring staff together and train them properly in the equipment. But I would point to National Grid and the DNOs in the UK that have addressed these challenges by having common technical specifications. And through the Energy Networks Association, they collectively assess new switchgear types to ensure they're safe to operate and maintain and meet relevant specifications and safety standards. And this has involved often the development of generic operational maintenance procedures that companies themselves can take and slightly modify for their own purposes. And I would encourage, those of you in the audience to have a look at that, because a lot of the legwork and good work on safety standards is done.
Gary, just a quick one there on the back of that, and thank you for that. Procurement of switchgear on technical specification aspects and the operation indeed of switchgear, the training of staff, it can be very complex, and I think we can all say it's at times convoluted in the UK when compared to the Europeans. You see value in that, or do you think we should change practices slightly?
I used to work for Siemens in the UK building GIS substations, and we used to have German switchgear in the early days coming unamended. And I don't make any excuses. The UK since, 1970s, when we first had the Electricity at Work Act, I think have led Europe and indeed the world in high safety standards. In fact, our fatalities in the UK across the workforce are some of the lowest in the world per head of the working population. So I think, we're on a journey in the UK to learn lessons from accidents, and a lot of the safety features and specifications take those lessons into account. And I worry that, we try and make excuses that, it's European or it's overseas equipment, we're going over the top. A lot of the reasons why we do what we do is based on accidents that have happened in the past. So I think, we don't need to be defensive, but we should, be robust in asking for and making sure we get certain safety features on equipment. Yeah, the last thing I wanted to talk about, not for everybody, but we're seeing it, which is, the challenges new technologies are being presented by manufacturers like battery energy storage systems, where we as owners, I think, and operators are a little bit on the back foot. And we've been caught out from things we've seen with getting up good operating and maintenance procedures in place. In fact, it's not uncommon we've seen for new HV equipment to be installed and commissioned without these procedures having been written. And a common complaint we hear from operational people is that they're not involved at the initial stages when this equipment is designed, procured, so that the operability and maintenance requirements can be satisfactorily addressed. Indeed, these systems are taking off in number, capacity, and complexity. Things like power electronic converters and battery arrays connected to the HV system are new to us. And the fact that the other challenge is the similarity and duplicate nature of this equipment means clear labeling and proper segregation in the design of the equipment is necessary if we're going to have a safe system of work. Indeed, we've seen that just working to isolations off a single line diagram will not necessarily mean you've got the adequate isolation for the work zone that you require. So we see the development of suitable safe operating procedures, clear identification and equipment, and training in these arrangements being really important, given that traditional procedures won't be adequate. I'd just like to thank you all for your interest and attention. And Chris, could I hand back to you maybe to reflect and answer some questions?
Yeah, by all means, and thanks for that, Gary. That's a very good insight into the challenges we face with implementing HV safe systems of work, in particular around human factors and processes and procedures. I think the human factor is something that often gets overlooked because not everybody's the same. Not everybody can react under pressure, to step back at times when they're under pressure and rethink things. And I think also, you've highlighted what those of us in management circles and operational safety roles, you've highlighted how we can play basically in addressing these challenges and making work on HV systems a lot safer in the future. I think in summary, I think what we picked out of the webinar today, that indeed networks are evolving, especially in the renewable sector now. And not only new technologies are out there, but there's the pressures that are associated with that and the methods of working, etc. The safety of the network, the safety of people on these evolving networks is also key. We have to keep pace with the change and keep that priority. And with all the effort of innovation, often we can disregard O&M requirements, etc., and often they can be an afterthought. So again, that's something that we have to remember. And let's remember, technology doesn't always make things easier. It can make things very, very difficult, especially the likes of isolations on the systems, etc., the likes of the battery storage. There's not a great deal of guidance out there on how to isolate these systems. Indeed, we rely on the manufacturers, and then it's up to the individuals or the organisations to develop their own procedures based on the back of that. And risk can never be eliminated, let's be honest. So we have to have robust and integrated safe systems of work that will, hopefully reduce the risk. And right at the end there, I mean, it's key, and I'm not telling everyone how to suck eggs here, but at the end of the day, it's not just a management decision. Work and safety needs buy-in from all, from top to bottom, bottom to top, left to right, right to left. Everybody has to be involved, and everybody has to be accountable and understand the consequences of any actions. So hopefully that's been a very good insight for the audience. We'll now turn on to Q&As. There's a couple of questions here which I've been moderating as they come through. I think one which I will throw back at the panel, backfeeds on LV systems by SSEGs. I mean, how do you control that? Any experience at all?
Gary, do you want to take that one?
Yeah, no, I think Mel raised this one. Yeah, this is the problem where, in the past we've not had embedded generation connected. It's not so bad at HV where, these generators are identified and we can take steps to, isolate and earth against. LV becomes difficult, particularly domestic, because, solar panels on people's roofs, they're not necessarily obliged to, well, they should connect and notify, but the DNO won't necessarily know they're there. And as Mel said, the only thing we can do is, test for dead. But really, the procedure's been to work under live as if it was live, because we cannot, if somebody comes back and flicks a switch or the solar panel now suddenly starts generating, we can't be sure it's been isolated, all have been isolated. So yeah, a real challenge, and thanks to Mel for raising that. I think the answer is, in short, add LV on domestic systems. It's changing procedures to regularly test, but work live in the absence of knowing every possible source of supply has been isolated.
Yeah, I think the key there, Gary, is, as you said, procedures. You have to adapt your procedures as the technologies change, and you've got to keep pace with it to keep people safe.
Yeah, thanks for that, gents. And just one more as we're getting near the end. I picked up on another one there. There's been a comment made. Do you think there's warrants having industry best practice for competency assessments? Do you think there's some water in that?
I think it would be a wonderful thing to have, although people's authorization structures vary wildly, although they're based on the same safety rules. And there's a bit of work to be done, but I certainly think it would be a step forward for the industry to do it, certainly.
Yeah, and I think Mel's raised a good point. We talked earlier about, we see human factors now. I know some companies are very good at, they'll do scenario setting, and they do look at, trying to gauge somebody's, whether they'll take risks when they're operating, can they work under pressure. I see it's a good opportunity for us to develop a set of guidelines around how to do it. We've certainly written company-specific competency and assessment procedures, and we do see some commonality, but I think now's the time we can be better. And I think it's right, we could probably, as an industry, try and do something together.
Excellent, thanks for that. Well, we'll draw this to a close if we could, please, because that's the hour up, and I'm sure you'll agree it's been very informative and a very worthwhile exercise, and hopefully the audience has been able to take away some pointers, etc. If you need any more information, details are on the slide there with regards to ourselves. You know, information doesn't always cost. We're here to help. So on that note, I wish you all well, and I hope you all stay safe.